Today we're talking about angles and triangles. The angles inside a polygon are called interior angles. Obviously the word interior has the word in or in it, so hopefully that will help you. When the sides of a polygon are extended, other types of angles are formed. The angles outside of a polygon that are adjacent, which is another word for next to, the interior angles are called exterior angles. So what you can see from the pictures here we have a triangle. Now you see these lines are extended, but it's partly for this diagram. The interior angles are the ones that are on the inside. We also have these other angles, which are not inside the triangles, they're on the outside. These are the exterior angles. So let's just talk about each of those separately. So the interior angles of a triangle, okay? Basically, the interior angles, hopefully we know, of a triangle always add up to, or the sum of, 180 degrees. In algebra world, we might say something like x plus y plus z equals 180. So it's information that I need to know if I'm trying to solve information about angles of triangles. So here's some examples of maybe how we might use it. So find the value of x. Well, hopefully we recognize we're on the inside of the triangle. So when we're on the inside of the triangle, we're going to use that information that we just talked about. That means that we have angle x, which is in that upper corner, plus 48 if I go down to the right and go clockwise, plus 32, I get 180. And then this kind of goes back to the beginning of the year when we were talking about how to solve equations for one variable. So remember, we're trying to get x by itself. So following our order of operations first, I can put those two numbers, 48 and 32, together to make 80. And then again, we use our opposite operations or our inverse operations to say subtract 80. We have to do it to both sides, which would mean x equals 100 degrees. Example B is a little bit more tricky, but really not much more. We should be able to handle that. So again, we want to keep reminding ourselves about what we've been talking about with the angles adding up to the 180 degrees. So I'm going to start with this upper one in the corner again. I'm going to add around clockwise for my three angles. So if I add the first one, x plus 28 plus x plus 90, we know that that would be a 90-degree angle for that box. It equals 180. So again, as we did back in the fall, we can combine like terms. X's can go to other x's, so x plus x equals 2x. I can add 28 to 90 to get 118. Now remember, we're trying to solve and get x by itself. This comes back to our SAD-MEG steps, so we work backwards. And then remember, when we did that, we would do our addition subtractions first to get 2x equals 62. Then we break away by dividing by 2 to get x equals 31. Now, sometimes this situation says, what is the value of x? Well, we just found it. The value of x is 31. Sometimes they might say, what are the angles of the triangle? And just notice that if they ask that question, we would have to do a little bit more work because this angle is just x, so it would be 31 degrees. But this angle is x plus 28. So we'd have to plug in the 31 and add 28 to get 59. So you just got to watch for your directions. If it wants to know just the x, we found it, we're good. If it wants to know the angles of the missing angles for the triangle, you've got to then plug them back in to solve for the expression. So again, here's another one. I would say x plus 81 plus 25 equals 180. I would have x plus 106 equals 180. And then I just subtract the 106. X equals 74 degrees. And then lastly, again, I'll start at the top. X plus 43 plus x minus 35 equals 180. Combining my like terms, I can get 2x. 43 minus 35 is negative 8, is plus 8 equals 180. And again, we're solving for the x, so I'm going to subtract 8 first to get 2x equals 172. When I divide by 2, x equals 86. So again, if we're just looking for the x value, it's 86. If I wanted to know what the angle measurements were, it would be 86 for this one, 86 degrees. And then this one would be 51 because I would plug in the 86 and subtract 35. So the exterior angle measurements. So exterior angles, if we just saw a regular triangle, you don't see the exterior angles necessarily. This picture is showing where they come from. So if I just saw a triangle, we're extending out a side. And this is what right here would be the exterior angle, in this case, Z. So to find the exterior angle measurements, there's a couple of ways to get there, but here's the most basic way. The exterior angle, in this case Z, equals the sum of the non-adjacent angles. So if you remember the word adjacent, the angle that's adjacent to Z is right here. It's the one just next to it. The one that sits right next to it is the adjacent angle. So if you look at the algebra thing of this, what we're saying is the angle Z equals the sum of the two non-adjacent. So y and x are not over next to z. The one that is this one right here. So really all we have to do is say x plus y equals z. There's other ways to get there. I can certainly work to find the inside angle next to it, and then we can talk about that in a little bit. But really the basic way to get there is just to think about the exterior angle equals the sum of the two non-adjacents. So now this one, notice it's not saying find the x value. It's saying find the measurement of that angle. So we got to remember that when we get to a problem that has a little bit more to it. So here is the exterior angle. It equals the two non-adjacents. So the 36 is not adjacent to it, it's not next to it, and neither is the 72. So I just have to add those two things together to get 108 degrees. And there's my answer for that x degree. The next one's a little bit trickier. So now our angle that we're looking for is this thing. So the exterior angle 2A equals the sum of the two non-adjacents. So again, the 80 plus the A minus 5. So now what I have to do is think about my multi-steps here. So I have 2A equals, I can do 80 minus 5 plus A. Now remember, when we have variables on both sides, you bring them together either by adding them or subtracting them based on what you're seeing, and we do the opposite. So I'm going to subtract A to cancel it on the right. And remember, I have to do it to both sides to get A equals 75. Now, the question here does not say find the value of A. It says find the exterior angle measurement. So here's where you need to take this answer and then say, okay, well, the measurement is 2A. So I have to plug it in to say that the exterior angle is actually 150 degrees. So you just have to be careful on those degree ones. Sometimes it just wants the value of the variable. Sometimes it wants to know the actual measurement of that angle. Okay, here's two others. So again, for this first one, pretty simple. The exterior angle is y. The two non-adjacents are 40 and 30. They're the furthest ones away from the y. So y equals 70 degrees. This last one is definitely more tricky, but we're just following the same pattern. 4n minus 20 equals 2n plus 20 plus n, and then we combine like terms. So I'm going to say n's can be added with n's over here. I want to get my variables on the same side, so I'm going to bring them to the left, mostly because it will give me a positive n when I subtract 3 n's. The 3 n's will cancel there. This will give me n minus 20 equals 20. Then I just need to add the 20 over, and again I add it to both sides. N equals 40. But again, is that the question? Not really. So we're going to take that information to figure out what is the exterior angle. So to do that, I'm just going to say over here, 4, we're going to replace the n with the 40, and then minus 20. 4 times 40 is 160, minus 20, 140 degrees would be that exterior angle. We are now entering the Bermuda Triangle, and we'll see if we can make it out alive. So here we have an example. You can see the Bermuda Triangle that's going kind of around this triangular shape from Miami down to Puerto Rico and then back up to Bermuda. So we have the angle interior measurements here of 62.8, 2x minus 44.8, and we're looking for the missing angle that is sitting right here. We're going to call that x. That's the Florida one. So again, we want to remember interior angles means if I add up all of my angles, we should get 180 degrees. So my first step is just to plug in the formula or the information that we know. The three angles added together, the sum is 180. So I can combine like terms here to get 3x. I have negative 44.8 plus 62.8, which is 18, equals 180. Now remember what we've said is we're solving for x. So going back to our SAD-MEG steps, we subtract to move the 18 first with that inverse operation. That will leave me 3x equals 162. And then I can divide by 3. X now equals 54. Now they want to know what's the measurement at Miami. So in this case, we want to find that X because that is going to be my answer. So we're just going to add the little degree symbol. The measurement at Miami is 54 degrees. So not really difficult. Biggest thing is to know if you are looking at interior angles of a triangle, they are always going to add up to 180 degrees. And then we're just using our equation building and solving that we did most of this year with the multi-steps and isolating x and reading the directions carefully. And then also looking at the exterior angles. And remember, the exterior angle of a triangle is the sum of the non-adjacent angles. Therefore, the angle's not right next to that exterior angle, the ones that are on the furthest part of the triangle. Hopefully this helps, and hopefully you will do well with this. And if you have any kind of questions, please see me in class.